Happy day to all. This is Dr. Nivedita, co-founder and chief physiotherapist of Sri Ahana Physiotherapy Clinic and Academy. This video aims to explain the basic concepts of vector in biomechanics. Vector is a quantity that has both magnitude and direction. For example, quantities like weight, force applied on a body, displacement, they all come under vector quantities. Usually it is denoted using an arrow, which shows the magnitude and the direction. Scalar is a quantity that has only magnitude and no direction. For example, distance between 2 points A and B is measured in terms of meters. This doesn't show any direction. When we study vector in biomechanical analysis, we must be knowing factors like magnitude, spatial orientation, direction, and point of application. Weight as vector quantity. Weight is the force exerted by gravity on an object. This has both magnitude as well as direction. Magnitude of weight is calculated using the formula mass into gravity. This tells us how strong the gravity pulls on an object. We all know that gravitational force is always towards the earth, so the direction is downward. Magnitude of a force vector. It is nothing but how strong a force is. Here, they don't tell us about in which direction it is applied, either it is being pushed or pulled. Moving to the part of spatial orientation of muscle force is nothing but the line of force, and that of gravity is the line of gravity. It is indicated by position of the shaft of arrows. Direction of a force vector is indicated by the head of the arrows. In the example, internal force is depicted with an arrow pointing upward, whereas the external force is depicted with the arrow pointing downward. The next thing that we are going to see is the point of application of vectors. The point where the vector arrow contacts the part of the body is the point of application. For the muscle force, it is a point where the muscle inserts into the bone. Point of application of external force depends on whether the force is gravity or result of the resistance applied by physical contact. Gravity acts on center of mass of a body segment. Push or pull, all the forces acting on a body causes translation of that segment. Direction of translation depends on net effect of all the applied forces, internal force and the external force. Because the muscle force is 3 times more than the weight of the forearm, net effect of both forces will accelerate the forearm vertically upward. In reality, forearm is prevented from accelerating upward because of joint reaction force produced within the joint surface. We can see from the picture that the distal end of the humerus is pushing downward with the reaction force against the proximal end of the forearm. The magnitude of joint reaction force is equal to the difference between muscle force and the external force. As a result of sum of all vertical forces acting on the forearm is balanced, the net acceleration of the forearm in vertical direction is 0. So the system is in static linear equilibrium. Vector in biomechanics is most often referred to the force applied. This has both magnitude and direction. It can be either the internal force created by the muscle or it can be the external force that is produced by gravity or resistance by other means. I hope the concept of vector in biomechanics is clear. Thank you.